All right, now we're to number 8. What do you notice that is different about number 8? Hopefully you notice that the two equations are not lined up. I see it's very close, that x is over x, y is over y, and the constants over constants. But the thing that's out of place is the equal sign. So we've got to rearrange these equations because the equal sign has to be over itself. So in order to make that happen, I really just need to move the y term to the other side. Alternatively, if I had not been forced to use elimination, I could have used substitution because it says x is equal to this expression. I could have plugged x into the other equation and solved. Eventually, you'll get to the point where it says just solve the system, and you get to pick what is the best method. And this is why we're teaching you all of them, so you can start identifying, based upon the equation, which one's the best method. Well, right now we're choosing to use elimination. We've only got a few examples left, but we're trying to just show you how you would fix this if you wanted to use elimination. In order to do that, this 3y needs to be moved over to the other side of the equal sign. So in order to do that, 3y is positive here. I would have to minus it from both sides of the equal sign, and the new equation on top would be x minus 3y equals 11. The bottom is 2x minus 3y equals 16. So now the x is over the x, the y is over the y, the equals over the equal, and the constant's over the constant. Now I can start trying to use the elimination method. The x's aren't canceling, the y's currently aren't canceling, and we are never looking for the constants to cancel. So I gotta pick which one I want to make cancel out. X does not currently have the common coefficient, but y does. They're both negative 3's. In order to make the y coefficients cancel out, I just need one to be positive, one to be negative. So the wisest or most effective choice is going to be to simply make one of these equations have a coefficient of a positive 3. I could do it to the bottom one, I can do it to the top one. I'm going to choose the top one. And in order to make a negative 3 into a positive 3, I need to multiply by a negative 1. Once again, when I do this, I have to make sure it goes to all three terms in the equation. So a positive 1x times negative 1 is going to leave me with a negative x. Positive 3y, I messed it up. Negative 3y times negative 1 is a positive 3y. 11 times a negative 1 is a negative 11. Now we're using these two equations and we're adding them together. 2x plus negative 1x is really leaving us with a 1x. The negative 3y plus 3y cancels, so there's no y's left. And 16 plus negative 11 is really 16 minus 11, so x is going to equal 5. We need to take this x value, plug it back in for y. Can use the top or the bottom equation, does not matter. I'll use the bottom one just because. We've got 2 times x minus 3y equals 16. The x value we found is 5, so 2 times 5 is 10, minus 3y equals 16. Minus 10 from both sides. Negative 3y equals 6. Divide by negative 3 on both sides, and our y is equal to negative 2. We have our x and our y, so now we have the point where they're intersecting at the point 5, negative 2. That should have been the answer to number 8. Number 9 is another one where it is not lined up. The equal sign on this one's way over here, the second equation's way over here. We've got to move some things around. All we really need to adjust is that this x needs to be on the other side. The x needs to be over the x, the y needs to be over the y though. So in order to move the x at all to the other side, I would have to minus it from both sides. So I've got a negative 2x plus 4y equals negative 8. The reason I wrote it that way is because the x is in front in the other equation, so I'm going ahead and putting the x in front in my first equation. So the other equation is 5x minus 4y equals 20. So now that the x's are aligned, the y's are aligned, equals aligned, constants aligned, when I go and try to add them, the x's will not cancel out, but I see that the y's will actually cancel each other out. There's a positive 4y and a negative 4y, so they'll cancel each other out. Negative 2 plus 5 leaves us with 3x. Negative 8 plus 20 leaves us with 12. When I divide both sides by 3, I find out that our x-coordinate is equal to 4. Plug that back into either one of the original equations. I'm going to use the top one. And I've got 4y equals 2 times x minus 8. We just found out that x is equal to 4. So 4y equals 2 times 4 is 8 minus 8. So 4y equals 0. Even when I divide by 4 on both sides, 0 over 4 is just 0. So our y coordinate is 0. So the point where these two lines intersect is the ordered pair 4, 0. I am thinking that the last two you can try on your own. So if you would, right now, go ahead and try those two problems in Nearpod. We'll come back and check and see how you did.